All right, so yes, we're now into the next part of our workshop. It's great to, with a really great keynote this morning from Nick. Thank you very much for that. So we're now going to have a few invited talks, three of them. First one from Luanne, then Grace, and then Chandra. So the talks will be 10 minutes long, 5 minutes for questions, something like that. Maybe there's a bit more time for questions as well. But on that note, let me hand off to Luanne, who's going to speak about past and future directions in task-based information environments. Luanne, please.
That's right. I'm pleased to have this opportunity, and I want to start. I'd like to start by acknowledging that we're meeting today on the traditional territories of the Coast Salish people. I live right up the coast a little ways, where I live and work on the traditional lands of the Musqueam and other Coast Salish people. I've thrown together some ideas, I think like many people here, still grappling with the many implications of these new technologies. But I've been working in the space of task-based information retrieval pretty much from my PhD dissertation. So I thought I would maybe start just by kind of situating my thinking around task-based, drawing on the research in this area. So I think of task-based approaches as tasks as goal-oriented activities, which is a very minimal definition, but it's actually surprisingly useful. And all the research has looked at how tasks can be defined at many different levels of abstraction. We think about different kinds of task types, work tasks, information tasks, lots of work on different task characteristics, like task complexity, for example. And of course, we recognize that tasks can also be viewed as in a process way, in a process model, and the importance of task stages. So that's that big picture framing. Why are tasks important? So for me, and I'm sure there's folks here who think about tasks differently from me, which is great. For me, tasks are really, they're motivating the information search, and they're establishing the criteria for search success. And so tasks function in this way as a kind of a context, a container that help us make sense of the search in a macro kind of way where we think about tasks extending over time and across search sessions, which is one of the challenges that task-based research has tried to address, these multi-session search. But they're also kind of more micro slice of time situational factors that are going to influence the kind of activities people are engaging in, the steps they take, and importantly for me and for my work, the selection criteria. So I'm really motivated by this question of how tasks and the features of the information that people are engaging with, how those connect and how we can use that connection to provide better search experiences. So just quickly, some of the work that I've done in tasks. My dissertation work was in an enterprise search environment, which is where I initially became aware just from listening to the people in that environment of how important tasks are in shaping their whole approach to information in that environment. So I looked at work tasks and information tasks. And the other thing that emerged from that environment was the importance of document genres, which now people didn't use the word genres, but they talked about reports and manuals and instructions and cookbooks and all of these ways that were organic to that workplace about how they thought about information. And then I looked at that also in the e-government space. I've done a fair bit of work that's more focused on the method side of things, looking at how we can design assigned search tasks in studies of information retrieval so that we're providing kind of consistent definitions of tasks, and we can begin to explore the impact of task on search in a systematic way. And then more recently, working in the area of searching as learning. Many of you will be familiar with that. For me, the idea of searching as learning, for me, learning is a kind of an information task. So searching as learning is a kind of a meta task environment. And in doing work in that space, one of the really important insights for me is that search systems that are designed fundamentally for different kinds of tasks like fact-finding, transactional kinds of searches, navigational kinds of searches, those are not necessarily going to support searching as learning. And so there's a different underlying model and, if you like, kind of value system that's embedded in the design of systems to support certain kinds of tasks and not other tasks. And so that's why it's important to me to think broadly about, especially as we move into these super-powered tools, to think broadly about the different kinds of searches that are happening. And so, as I mentioned, this connection between features of information and that are supportive and valuable in particular task environments is really where I'm thinking. And so just a quick example of this idea that information has characteristics that are important to tasks that we don't really even consider in our field. This is just a list coming out of my study looking at software engineers and how they use information to complete tasks. And they identified characteristics like the level of detail of the information is extremely important when you're trying to choose a document to help you complete a task. Whether or not the information is officially approved or not, whether or not the information was produced through a real first-hand experience, or if it's second-hand knowledge, the specificity, the purpose, etc. So just examples to make the point that information is a very, very rich construct, that people use to communicate with one another, and there's just a lot of stuff in there that we're not necessarily capturing and thinking about all the time. This is my attempt at a Brenda Dervin sketch, so please enjoy. This is a concept that I want to kind of put forward here. Not necessarily particularly novel, but I think it's an area where something that we could do more now that we have these tools that we couldn't necessarily do before very effectively. And so the concept is a kind of a task-based information environment that would be a particular IR task where you dynamically generate an environment for a user that is it's influenced by the task, which sets the conditions for that environment, and then that becomes a space in which work can be done. And so some of the features that for me stand out in this environment are that the information could be tailored to the task, thinking about those specialized characteristics. Now we could actually think about systems that write the information, produce the information for the task, although I'm not sure that's my preferred way to go. But anyway, the information is tailored to the task. We take into account that there is a task process, and so the system also might sequence or present that information in a way that's also tailored to the task. So there's presentation and sequencing logics that are task dependent, and then the interaction tools and protocols for interaction in that space would also be task specific. And of course that could be things like a co-pilot or a chat-based assistant, where my argument is that the nature of the interaction, even the simulated human-to-human interaction could be task specific. There are tasks where there's, there could be a kind of a deep emotional component. There are tasks that are very, business-like, and so the protocols of the interactions could be task-dependent as well. For me, the notion of human agency in these spaces is really important. And so I don't want to jump right past, obviously these machines can complete all sorts of tasks for us. I don't want to jump right past the component of human agency and be sort of completing tasks for people, because we have this really important question, I think. Which tasks do people actually need to do themselves? And learning is a classic example. Maybe there's some kinds of learning that, yes, you can hand off to a machine, but if a human being does not invest effort in engaging with information themselves, then they're not going to learn. And we need people who are experts, and we need people to develop knowledge. That's why we have education systems that try to train people to do that. But some aspects of learning, yeah, we can hand them off, but we don't know yet what those are. Creativity is another question, where does that lie on that dimension? And I want to flag also this idea that, I want to encourage bigger picture thinking, more holistic thinking about this whole space, because, we can't, I don't think we're at a place in time where we can consider that there's a consistent set of values that can be human values that can be reflected in an information system, and it's going to serve all people. People are already frustrated with some of what's happening in the search engine space, that the web seems to be a little bit less interesting than it used to be, a little bit more formal and bland, and people are going to TikTok and they're going other places for information. So how do we think about investing values or even giving the user agency to establish a set of foundational goals or values that would actually then shape their specific search experience? We can do that through personalization. We can try to guess what's important to people, or we can try to model that somehow automatically, and that's another way to go. But somehow, I think we need to think at that level, because for me, this is a big shift when we move from giving people a set of documents to crafting a response to them. That shift in responsibility is huge. And I think these are some of the questions that we need to think about. So I'm maybe already a little bit over time, so I'll just be quick. I mean, the opportunities I think I've already mapped out, and I'm just thinking here in terms of this generating these task-based information environments. We can reveal more of these features. We can model tasks more thoroughly and create these environments. And we can develop chat-based agents that can provide support in those environments. I've been doing a little bit of work on this, looking at, for example, a project with a student doing chat-based interactions to try to prompt critical thinking in the social media space, and basically programmed different personalities into the chatbots and tried to understand, if people are interacting with these chatbots that have different personalities, how does that help or hinder their critical thinking skills developed through that conversation. With Alice Lee, who's here, we're looking at query bias effects and trying to investigate some of the rhetorics in the responses that systems, in the dialogue conversations that are happening, and how that could potentially affect people's attitudes towards information. So I have all sorts of concerns about generative AI, and I think I've touched on some of them. The point that we need to think about the increased level of system responsibility in moving to these different models, the very high potential for manipulation and value bias in these interactions, where there is a kind of a model, and that's the one that everybody's encountering. The problem of misinformation and machine-generated goo was the term I came up with for these very, very bland machine-generated kinds of content that, like, nobody wants that. This is just all the fun of the internet sucked away. Yeah, and so I hope that there is time for thought. I hope that there is a slowing down and there's a broadening of perspectives and there's more regulation on these kind of systems, because I'm not interested in a world personally where most of the information content is produced by machines. Thank you.
Great. Thank you very much for the excellent talk. Any questions from anyone? Yeah, go ahead.
A clarification question. So what are you considering outside? Are there things that people use search interfaces for that are not tasks?
I think that there are activities that are less goal-oriented, and so I would classify them as less task-based, and those would be hedonistic, entertainment-based information interactions, could be emotional support kinds of interactions, which we know happen. So that would be the line I would draw.
Wait a minute, but wouldn't it depend on the definition of task?
That's what I'm asking.
Yeah, that's why I use my definition.
Everything is task, if you think about it.
You have a goal to entertain yourself. That's,
Yeah, sure. Yeah, you can go there, but I think that the idea of the goal-oriented framework for tasks is just that it does establish some conditions. Whereas if you're talking about these other kinds of activities, it's very hard to determine, in my view anyway.
I like the point that you made about giving a set of documents versus giving an answer. And I've long thought about Google's brilliant marketing trick of putting that "I'm feeling lucky," which essentially pushes the onus of responsibility onto the user, saying, you suck today, and so this is what you're going to get. So, rather than, the system doing it. So is there something equivalent?
Pardon me?
Is there something equivalent in
Yeah, but I think we're past those days. Like, I think that the search engine companies are no longer saying, "Oh yeah, but it's just an algorithm. We didn't intervene here. We know that there's censorship in content. There's a whole bunch of rules. There's a whole bunch of quality parameters. There's so many ways in which those responses are crafted, designed by a machine, whether or not there's full transparency about it. But I just don't think we're in a point in time where we can say, it's on you, user. We're just going to shoot you some results, and it's up to you to deal with it. I'm sorry, I'm over characterizing what you're saying, but yeah.
So,
Sorry, Brian, you're
No,
supposed
it's
to be
fine, no worries. Vanessa, Rob, Life.
so we've had, large-scale, widely available search engines for more than 20 years now. And the search engines have had the same basic format the entire time in terms of results presentation, which is a title, a little summary blurb, and there's just a list of these things. Do we know, or has anyone measured the degree to which those summaries have become more generic over time, or less diverse in terms of the language or the concepts? Because I'm just wondering if people are learning less as they search now compared to 20 years ago, and if that would be even more true with generative AI, which has a particular type of smooth language.
Yeah, I don't have data on that, and I'm not aware of studies on it. I think there is maybe more anecdotally, and maybe there are some studies somebody else knows about, this idea that diverse voices are not being represented to the same extent. And for me, I think of, when Google introduced the quality criteria, then that websites that have great SEO are going to get ranked higher. And lots of organizations and people and groups do not have resources for SEO. So that's sort of where I think the differences happen, not so much in the sort of descriptions. And anecdotally, right? No, not making any. This is a workshop, right?
Exactly. Yeah. Go ahead, Rob.
Yeah. So, Luanne, I really like what you were describing about this trying to understand the learning that's happening when people are engaging with these, right? And we've been thinking about this a lot in our research group too. So my question is sort of around, there are times where I can see that a person grappling with search results and having to sort through and do the synthesis themselves leads to greater understanding, greater, deeper learning. There are other times when I can think that having a nicely concise, synthesized answer presented to me could actually lead to better or more efficient learning. And I'm curious about, how do we evaluate those? How do we assess when one of those situations is better than the other, or when one works more appropriately?
Yeah, good question. I think about that in terms of kind of scaffolding, and if we want to think about it in a task kind of model, then you might think about where somebody is in that process, and maybe even a information seeking process model where do you intervene, and what kind of support do you provide at different stages. So maybe if you have the full search session or you have a history, then you could model that. Yeah, thanks.
Awesome, thank you. Life?
So I'm glad you said it's a workshop, because my question is ill-formed here. So you sort of mentioned this shift in responsibility, and that there's this transition, and I was hoping you could elaborate on that a little bit more, especially with regards to your comments about how you're saying that the machines create this blandness response, right, in one thing, and you don't want to live in a world like that, yet you're saying that the systems need to have responsibility, but the systems tend to become more bland because they're being more responsible.
Right.
Right, and then you're saying, well, okay, if I understand correctly, then you're saying, well, it's not, the user has to take less responsibility because we expect the system to be more responsible for the answer that it's giving us. And so maybe you can unpack a little bit of that, like who's responsible for what? If I'm asking a question to the system, is it my responsibility what that answer is if I ask a leading question? Or is it the system's now responsibility to tell me how I should ask my question and what I should expect to have, and this is how I should be thinking?
Yeah. Well, I think we need to work a lot of that out because, you know, just in my classroom, having students use the Gen AI search systems, there were some answers that the search system was being very normative, like, this is the way you need to think about this problem. Like, it's not okay that you ask that question, essentially. And then others where it was very standoff. It could be this, it could be that. People think this, people think that. And so I guess my concern is that interactional component, like the blandness maybe of the documents that are created or ranked highly or included in the response is one thing. And the other is the nature of that interaction and how much of an influence it could have in shaping the sort of the knowledge experience of that person, the information experience of that person. And I don't have an answer, I think. I mean, obviously, you know, transparency is one thing, giving the user the ability to change settings, like, you know, their settings more verbose, less verbose, the responses kind of thing, but is that really what the setting that we want?
Yeah, so I mean, it sounds like you're also talking that there's one centralized intelligence as well, whereas you could have a different model, which is having many different types of generative AIs that you could interact with of all these different types of personalities.
Yeah. Yes,
But
and I think that's one answer.
Really
So I'm more
flesh
articulating
out.
the problem than the solution, I think.
Yeah, no, it's great that you sort of bring this up, and but it's a very tricky space between the system telling us what we should be doing and what we should be thinking.
Yeah.
The potential biases it could bring in, both for good and for harm.
Yeah.
Yeah, I think that's a really good point. Maybe, I mean, I want to make sure that we get onto all of the talks. Excellent questions. Thank you so much. Yeah, I think a lot of the questions we have we'll get to over the next day and a half as well. You know, there'll be a lot of opportunity to speak about those. All right, so I wanted to introduce the next speaker. Grace. Grace will speak about reclassification of information-seeking tasks. Please go ahead, Grace. Thank you.
Thanks, Ryan. Thanks, Sheriff, for having me here. It's great meeting everybody here. Yeah, I will be quick for my talk. Yeah, so today, very happy that I want to share with you some new thinking of me and my student, Zhiwen, about taxonomy of information seeking or maybe task-based information accessing behaviors in general. So here are some wonderful existing taxonomies by Gary, by Ryan, and also by some, Arthur Corolla in recent years. So you can see this definition kind of trying to classify those tasks or like search-based tasks, like lookups, learning, investigation. Ryan actually came out like a Venn diagram. I really am fascinated by the Venn diagram. It's kind of trying to put exploratory search, sense making, a berry picking and retrieval in like different places, and then also they are overlapping as you can imagine, right? But when we really think about it, like for myself, I kind of feel it's a bit hard for me to not be confused by some of that. And then I kind of realized that those previously defined taxonomies, they're more from this kind of a noun definition. So they're focusing on what the task is, or what it is, kind of noun definition. In this talk, actually, I would like to talk about like my own thinking about really look into the tasks' computational nature as well. But I want to say that we're not trying to offer algorithm, right? So some like comments that we receive from reviewers that, oh, you're kind of like mixing the task itself with the algorithm you want to use. It's actually not. Here, I just want to talk about the task. By trying to, classify these tasks from more this action or the process or verb-like definition. So part of that, I think maybe it's because of I came from the East, right? So there's some interesting study. They study like English-speaking or Western country babies, and like people from East, and in the first year, the like Chinese babies they learn more verbs, and in the English-speaking country babies they learn more noun. So I think maybe, I can contribute something from the East point of view. Right. So this is something that we kind of came out, kind of like talking about some new dimensions about those, information-seeking tasks or tasks in general. So the first dimension is it's one step or not. If it's one step, then it's ad hoc retrieval, and if it's not, then it's more like an interactive thing, right? And then the second dimension is whether the goal of this task is telic or not. I will explain what is that, right? So telic means, they really have focusing on like an achievement, get things done, right? So if it's not, then maybe you're doing like multi-turn QA, kind of like interactive, but it's more focusing on multi-turn QA. And if it's not, you're like focusing, you start a task just for fun, exploratory, and then probably as an exploratory search, right? And within multi-turn QA, and it's also important to look at the last dimension, which is, do you have a goal in the end? That means that do you want to complete the task, or do you want to win the game? Or like if it's playing a soccer game, you really have a goal in the end, right? So if that answer is yes, that's task completion. And if it's not, right, then maybe you're just collecting rewards or gains along the time, right? There's no upper limit, but there's no end. Okay, I think the first dimension is very straightforward. Okay, so we'll start talking about the second dimension. Second dimension is actually inspired by a psychology study called a reversal theory. Yeah, so they kind of defines the 4 domains of human motivations because the task is actually started by a human. Well, maybe GPT can start a task, but like when we have the paper, we're assuming that the human starts the task. So when the human starts the task itself will have kind of bearing this human starter's motivational status. So that's something we call the goal types. And we mainly only use the first domain, they call the means end. So basically they classify the means end like a 2 spectrum. One's telic, user is motivated by achievement, like task completion and fulfilling of goals. And paratelic, the user is playful and seeks excitement and fun. So for example, when people are having telic goals, they run because they want to win the medal. Okay? And if people start with paratelic goals, they run because they enjoy the running itself. See the difference? Okay.
Can you do both?
You can be both. Yeah, but when you start the task, we're assuming, maybe there's one, major one, primary one. So if you're curious about the other, motivational states, so the first 2 are actually about this individual user, right? It's means the end, and whether the user is conforming to rules or not. And the last 2 are actually about the interpersonal relationships. So this is just a slide from their paper. We're just making use of the first ones. But I think other things could also be quite useful. Anyway, that's our second dimension. And the third dimension is this tasks go converging or not? Yeah, so like converging goal, like you close a deal, you make a purchase, right? Or you follow a recommendation made by the machine, you book a ticket, you win a game. You get something in the end. Non-converging goal, like, get much awards, get more answered correctly, or get more relevant documents. So that's kind of accumulating. And so that's actually how we want to classify the tasks. And I kind of draw some task illustration. I think if it's cumulative, the task actually just want more. So you see kind of like increasing straight line. But if you want to be successful in the end, like you have a goal in mind, right? In the end, you have a goal. So it kind of exploratory, but eventually you need to hit the point, the red start. And if you're just having a parenthetic goal, then you can be random anywhere, right? And if you look at the gain curves, by the way, this is not scientific, just really draw by myself. So that's also some kind of, like increasing gain curves, cumulative goal. And if you look at the gains for the converging goals, so and the talic tasks, so they can have some gains here and there, and eventually they have a huge one, yeah. And if it's exploratory, that actually can be random. And based on that understanding, and then I will start to recommending like different classes of machine learning algorithms maybe will be suitable for solving them, yeah. So I will actually go into them, very briefly. There's a first group I call the local method. It turns out that they are actually, a lot of them are actually introduced by our IR community. Those methods, they are stateless because they're not really considering things like events in sequence, like relevance feedback, like query formulation, query reformulation, expansion, query weighting, including active learning. They're local because they're not talking about the tasks, entire task, but like right now, at this moment, I'm doing right. Band-aid algorithms. Band-aid algorithms are widely used in recommender systems. They're still stateless, but they're kind of taking into account this local context, like choose the best action to max some longer-term cumulative rewards, yeah. Or eventually the user will close the deal in the end. More complicated ones will be like this reinforcement learning agent, right? So here I'll just jump into this model-based reinforcement learning agent. So the algorithm and actually doing like two parallel learnings. One learning is something we call this environmental model learning. So the agent can try very hard. Actually, it's kind of like supervised learning to understand the word. Like for example, in our context, will be to understand document collection, like user, and the user like a lot of understanding about user is actually belonging to model learning. But at the same time, it's doing this kind of like policy learning. It means okay, which will be the best document, which will be the best next word I'm going to say to user, or what will be the next answer. And it's like, trying different strategies and eventually to achieve something, yeah. So I think for, okay, come back to these slides, then the model-based will be those, those goal-oriented tasks. Yeah, I think they will be very suitable. And for like the local method and band-aid algorithms, I think they will be wonderful for these cumulative gain tasks. Yeah. And of course, like all of them actually can be used for exploratory search. Yeah. And all of them can do imitation learning because they can just learn from a human, how humans do. Right. Yeah, this is like open-ended reinforcement learning. Yeah. So that's like a toys paper. Okay. And another thing, this will be short. It's like pretty recent, but it's like 2021. We had a workshop paper, NERPS, about a human in the loop. So in that, we kind of imagine the agent. So here, what we did is for self-driving car agent, right? But you can imagine this is ChatGPT, okay, or a GPU model. And where even there's a human is actually there to coach this RL-based trained agent, right? So basically, we just talk and like speech to text and like some transcript, but there's transcripts that just like human coach. Like for example, if you use a search engines, I don't like this search result. The result is dumb. Can you just remove that query? Something like that. And kind of those kind of action, those words will turn into either actions or direct rewards, and to kind of really directly influencing, interfere the agent's learning. And so our paper is called Incorporating Voice Instructions in kind of training those model-based reinforcement agent. And the blue line is ours. Okay, the yellow line is like the PPO. Yeah, it's if you know, like ChatGPT was actually using PPO as a backbone for the reinforcement learning part. So it's actually quite effective, how to say. Yeah, actually, I'm done with my own talk. So this is just a paper that I just mentioned while, for Nick's, during Nick's talk. Yeah, so it's a pretty recent paper from Harvard Business School, and they're talking about these AI capabilities are actually jagged, right? So some parts is doing well, some parts is not. Yeah, questions?
Awesome, thank you very much.
And we're called for sponsorship.
Product placement.
I love it, thank you so much. All right, please, yeah, go ahead and
Great, thank you very much for. I like your classification of the seeking task, but at the same time, I also get reminded that Yuelin Li and Nick Belkin in 2008 published this facet classifications for conceptualizing information such tasks, and they actually mentioned some things quite similar. I just don't know whether have you looked at them, their studies, and recognize any differences, connections?
Yeah, I closely followed his work around like 2014 and 2015. I remember that he came out from this contingency table with the task goals, but I think it's different from what I'm talking about here. The 18 I haven't.
2008.
2008. Oh, 2008, and then maybe. Yes. Yeah, I think I agree with that. So that nothing about these existing ones I disagree. It's just a different point of view. Yeah, I think we're talking about like probably the same thing, but we're understanding it from like different ways.
Thank you.
Fernando?
Yeah, Grace, can you go back to the table where you, yeah, so the bottom row where you're talking about the machine learning methods, like, is there anything specific about the structure of the task that means that these are the optimal algorithms, like theoretically? Because I guess I didn't get that impression from the slides that you presented afterwards.
Yes, that's actually what I'm kind of talking about, a pairing of what is the best pairing of the method, machine learning method, and if we know the task nature, the nature of the task structure. Yeah. Yes, I was trying to come up with a pairing, but I have to say this is really our group's personal view. And by the way, this is a survey paper, so we're not proving anything.
All right, any more quick questions? Yeah, please go ahead then.
I have a question regarding the new dimension with the classification. So I wonder if we build a proactive search system or generative AI, how we can ask user to, like, if we ask question, we let the chatbots to ask user question if they want to do this task, or we can predict users' goal or their other classification based on their interaction. So how do you think we can build that proactive system?
Well, I don't know how to directly answer your question, but there's a few things I want to say. So first, a task is started by a user, Right. So those things are actually trying to classify the task and the user together. Yeah. And the second thing I want to say is that my current position is I actually view a large language model as a being, B-E-I-N-G. They're actually more than a search engine, which is a tool, right? So how users should like interacting or expecting from large language model, I think the equivalent will be how you're expecting to interacting and work with another human being or a grad student.
All right. Anything else before we close? I think this is for time. Thank you so much. Great. Thank you.
Okay. My name is Chandrasekar, and I go by Chandra. This is work with, some of it was done by a summer student, Kelvin Christian. So I work at something called the Institute for Experiential AI, which is part of Northeastern University. I'm based in Seattle, and I'm kind of Northeastern, the Institute's Seattle branch, so to say. I'm going to be talking mostly about the problem, the data collection we did, give you some preliminary numbers, and give you a broad description of what we are planning to do, and tell you why this excites me. It's to me, every time I see an irregular table, it makes me smile. So in Grace's talk, I found a table, so I quickly took a picture, and it's part of the slides now. So, okay, so the impetus came with some consulting assignment I did a while ago with a pharmaceutical company. And essentially, they had a ton of what they call new document applications. And for each new drug they want to get into market, they have to do a lot of paperwork. Okay, and it actually is like a book. Each of those documents is like 300 pages long, lots of tables, lots of text, lots of figures. They wanted to be able to search through all their prior collection of documents, and they didn't have institutional memory in people. They wanted to be able to do search on that. They wanted primarily to do paragraph level search, but they said, hey, it'll be great if we can do tables, and why not figures too? We said figures we'll put aside, we'll try tables as well. And these are all scanned pages, not born digital, that created some complexities. They are what I would call complex tables, and I'll come to the definition as we go along. But typically, they look like a page of text. There's tables, there's text. This is not from a new document application. I had to destroy every bit of data they gave me when the consulting was over. So I'm not allowed to keep that. This is from a drug pamphlet I saw in my doctor's clinic and stole. So, and then I've been taking pictures of that and put it there. It's just a pamphlet, so it's not a big deal. So there are captions below the pictures. There are several tables in multi-page tables, like the table which is right down. For some reason, my mouse is not showing up there. But anyway, like the table which is on the, hello, mouse? Yeah, there you are. So like the table here, this has been split across pages. So there are complex tables there. So we focus only on the tabular information, and we did a decent job. We had to do a whole lot of kludgy things. We had to put in heuristics and so on. Say in that all those documents, the caption was always on top of the figures, so we had to go looking for it there, look for bold-faced text, and pick it up as a caption. And that's really very task-specific, and it worked. It wasn't perfect, but they were happy, so that was good. And the question is, today with today's tools, with generative AI tools, can we do better, and how can we do better? And so the goal here is now, can I go even a bit further and say, can I do question answering, which is what we tried to do there. And they were ready, they were happy with just being given dollops of paragraphs there, but they wanted to be able to answer questions like, what is the color of so-and-so drug formulation, or what is the auger definition of this drug formulation, and so on. And they wanted to answer, if possible, as a constructed, generated answer there. Now, irregular tables are all over the place, and you'll see them. Now if you keep your eyes open, you'll see them in scientific documents, medical documents, pharmaceutical documents, especially. And there's been a lot of work done on HTML tables. There's been a lot of work done on regular tables, which are just so many columns by so many rows, but not so much here. So the proposal here is to create a big database of tables and extract and represent canonical information. And we thought we'd start with the archive database, which has slightly over 2 million papers there, and extract the source, typically is in LaTeX, and the target side, which is PDF, and try and see if we can do some learning from that. Okay, and then once you learn the mapping, do question answering on top of that. So you feed in PDF at one side, you go through these stages, which has been very nicely described in this paper. So do table detection, where you just detect the table on the page. Then you go and find out where are the columns and where are the rows. And in the table functional analysis, you actually find out what is the semantics of the intersection of the columns and the rows. Okay, so the stretch goal for me is a document representation idea. So there are simple things that bug one. So can we have an interlingua? My background is machine translation, so I would say in machine language terms, can I have an interlingua for document representation? If I'm cutting and pasting from Google Sheet, my colleague Ken Church pointed out that when he copies from Google Sheets to PowerPoint, it actually converts some of the formulae into the equations into images because he doesn't want to make mistakes there, so they put it out there as an image and you can no longer edit it. PowerPoint, I don't know what you see here, but you see I put in a left arrow and a right arrow on a Mac, and it became a little box on a PC. I have no idea why. And actually, when I tried the same thing on an online version of PowerPoint, the box disappeared. There was nothing there. So I don't know what's happening there. So anyway, the question is, can I cut and paste across applications? This sounds like a trivial task, but it is not possible. This is, you want a generic interlingua which to make it do this. I don't even want perfect. I want to be able to edit it. Put it there with some mistakes. I don't mind occasional box there. I'll go and fix it. But I would like to be able to fix it. Now, irregularities, we mentioned some of them. You have things, you have headers which go across columns. You could also have headers going across rows. You could have irregular cells like this. This is about blood cells there. And if you look at erythrocytes, there's just pink column at the top. It's all in one column, one row, multiple columns there. But the leukocytes, which are this whole thing, the first column applies to all but the very first row and the very last row. Okay, so, and this particular, and then if you notice there's other divisions within that, and some of the cells have images in them and so on. Plus, in this particular table, they use color. We're not worried about the color part of it, not a focus, but there is interesting variation there. Then you have nested tables, which I find the most fascinating and interesting. So when you have, this is a very artificially created HTML version just to show you what it looks like. This is a real one, again, from the Ozempic package insert there. So inside a cell, they actually have a whole table there. In this case, it's just a table with 2 cells, but it is complex there. How do you interpret this particular cell? How do you, if I had to do question answering on that, think about what you would do to that. Now, the other thing that I mentioned is a lot of tables have footnotes. They have captions, which most table software, you go do a search on table extraction. They all extract just the table, not the caption, not anything below it. And if you find there's a ton of information which is below the table, it's all very interesting clarifying information there. This is, thank you, Grace. It's not very clear. I had to do a quick job of that while you were talking. But anyway, so you have things here where you have images there. Here you have a row which is spanning multiple columns there, images within cells, and so on and so forth. Sometimes you have lines dividing columns and rows. Sometimes you don't. You have a whole lot of variation there. So there are 3 papers I just want to briefly mention. Table Bank, which was done by people like Ming Zhao, who was at MSR Asia, and a bunch of students in Beijing. And and if you look at the highlighted part, you'll see that when they do tables, they get about 70 to 78% accuracy there. There's other work which I would love to meet the authors there. Microsoft Redmond people who've done something called pub tables. They collected a bunch of data. They're getting for complex tables. And their definition of complex is different from mine. But anyway, they get about 70% on that. And very sadly for me, must be happening to everyone here, about a month ago, somebody has done a lot of the stuff that we were doing, and they took the same archive data set, they extracted a PDF and LaTeX, but they did other things. Their definitions are different. Their focus is on equations and text. my focus on tables. But on tables, they get about high 70s. So to me, that says, hey, there's stuff we can do there. So I'm not giving up hope yet. So what we did was, we initially, like I said, we wanted to use a machine translation kind of an approach, map LaTeX to PDF, learn from that, and use that in understanding and responding, doing downstream applications of table understanding. So we created to create the corpus, we took all the LaTeX files from archive. It's slightly over 2 million files. And we found out about half of them had at least one table. And similarly for PDF, we took the table and then we wanted to map the PDF text to the LaTeX text. PDF is the hairiest thing I've ever dealt with. Nobody in their right mind should be doing that, but it works. But so it's good for one thing, not great for this sort of application. We actually decided we'd extract the image of the table, then do OCR in it and map it to the LaTeX there. So we took 2.84 terabytes of the PDF files. That's slightly about 2.2 million papers. And we are just processing it still. It's only about a fifth of it has been done. And one of the things that we found was when you started in 1991, there was about 5% of the papers had tables in them. Today, over 60% of them have tables in them. So there must be like, you want a paper accepted, you better have a table there kind of a rule maybe. So remember, students, at least one table. Okay, so now what you have is, we have the LaTeX file, we have the image that we extracted. From the image, we do OCR, and then we shove it through an alignment code. We have to, the order of the tables in the LaTeX code may not be the same as the order in PDF because things change around, positions are different. And so we had to do some matching. We tried also some matching, still done a very simple jacket similarity that worked the best for us. As we are processing, we have about 131,000 match tables right now. So we are still doing all this there. We have to finish the extraction, we have to finish the alignment. What we hope to do is when we're done with this, the first stage of our deliverables is to push out a bunch of all the tables that we get with the matching LaTeX to PDF. So anybody who wants to do anything with that. And we'll also push out the OCR for each of the tables there. Plus we have the full OCR of every paper that we looked at. So you have the full text of that if you want it as well. I'm not sure about all the copyright issues. We have to figure that out, but we'll do something about that. That's where lawyers are. Then model the tables to QA and all that. And my institute has, I believe in this, and my institute believes in having humans in the loop where it makes sense. And I have some ideas about that. We've done some thinking about that, not gone very far. Now, in addition to the goals that I mentioned, one of the things that was very clear was that people are using much the same data. It's what you can get, right? And then people use different structuring mechanisms, they have different focus. But you have the archive with the PubMed data. You go from Word to LaTeX or PDF to HTML and so on and so forth. And people have different focus, right? Either on the pages, the tables, the equations, or the tables, irregular tables. And there's a lot of underlying tools that we're using. And as with every other science, people working on will solve the problem. Now, our field has been so incredibly sharing, but I still keep thinking about Banco and Brill's paper in 2001, where the more data is better. And later, Peter Norvig and Alan Levy and somebody else had a paper in 2016 or something, where they talked about more data is better, but using different language there. Idea is, can we emphasize data collection and sharing, and can we do something even more to share things? Can we collaborate? How do we get other people to join the fun? How do we get people to chip away at individual parts of the problem? And if you have ideas, do come talk to me. Or tomorrow when we have a session, when you had that open session, maybe this is one of the things we could talk about. So collaborate is okay. So before I go, so that's all about tables. But two related things that I've been working on last year, Ken Church and a bunch of our colleagues, we have been very worried about some of the things that risks. There's been these risks that people have been talking about of various things to people. the biases that people talk about, we classify as risks 1.0. Risk 2.0, we classify as things that social media companies, in their quest for power and money, if I can say so, we actually Ken had a stronger wording there, are doing various things. And even yesterday we saw a report, front page news, about what's happening in India. And then Ken and I wrote another emerging trends opinion piece on looking at spyware, the Pegasus software from Israel in particular. And we talk about that. If you're interested, have a go at it, and I would be interested in comments on that. Thanks.
Thank you very much.
You're finishing time.
All right, so we have time for a few questions. Anyone want to ask on this one?
So I do actually have a question. So my question is, you transfer the PDF to the image, correct? And then you extract it from the image?
From the image, we extract we do table detection using the table transformer from the pub tables people.
So if I, for example, so it's interesting. So if I scan a PDF, that would be better. You use that one. You can use the JPEG of it.
Correct.
Much better than actual PDF.
Okay, so the problem with all these systems is that even with the table transformer is that we have to actually fiddle around with it. It doesn't matter whether it's born digital or it's image, like you're saying. It actually leaves out some of the corners there, so we have to do some fiddling.
That's what exactly happened. It's like shaking the stuff.
Well, lots of things happen when you're scanning on an actual scanner. Then things get skewed there. And if you look at the NuGet paper, they have actually, when they do data augmentation, they actually control for a lot of those things in a very interesting
So you
fashion.
can control on that one, then you basically extract the data and reach
We have not done that. So what we decided was, we said we'll take only high quality tables. And currently what we're doing in this pass is, we are just putting an exceedingly high threshold for the quality. So if we don't get that quality of matching and quality of goodness of the table, we just toss the table. We don't take it into account.
Okay, so that's interesting. I'm just going through that one. I can talk about, if somebody has a question, I can talk about it after, because when looking at the industry, it's like majority of there's a lot of, the number of the high quality tables is a lot less than actually.
Yes, and the other thing that people don't realize is, and this is a project, the problem we had with the earlier project as well, when paper becomes yellow, the acid-laden paper, when it becomes yellow, scanning becomes really hard. And so there's a lot of noise in the system, and then mapping it, getting decent stuff out of that. OCR is bad, getting table content is bad. So it's not an easy problem. Dave?
No, it's not.
I can talk to you more, but
Yeah, we'll talk about it definitely.
All right, great. Thank you very much. We have time for one more question. There's two hands. Sure. Go ahead, Life, and then down here. Yes, please.
A lot about extracting all the tables. I just wondered if you had a couple of quick comments on what kind of generative tasks you're imagining from that content. Like, is it, oh, now I have all these tables and have all this data, I could generate like a meta-analysis from the data that's already out there, or that's what a systematic review would generally do. Or I could generate the table for my next paper so I don't have to do the study, so I can make it easier to get published without doing any work.
No, this is, the task is started out with the original, and there's any number of things that you can do now. But the task I started out earlier was question answering. They were so what the pharmaceutical company wanted to avoid doing was to repeat things that they had done before. So they wanted to know about processes that they had done. So they wanted to integrate information across the text, image, and figures there. We were able to do search on the figure captions or on the table captions, but not inside the tables initially. Later, we were able to do the paragraphs. We divided the whole 300 pages and every 300 pages into little paragraphs and overlapping paragraphs and stuff like that, and do a mix of paragraphs and text in the tables plus in the captions. And we were able to answer questions. We want to be able to do things like, like they have a formulation method, and they wanted actually details of the mechanical engineering which went into that. There's an auger which goes and makes sure that you have precisely 200 milligrams of something in a capsule. the design of that auger. They wanted to know the design of the auger. So we had to actually get not just the text of it, but if possible, also get the figure of it and stick it in there. So I can imagine all sorts of complications there. And I think it's not limited by what you can do. I think these tasks just pop out to this.
Yeah. Awesome. Thank you, Tim. For one last quick question, do you have something? Okay, quick.
Actually, I had the same question. So, well, the possible generative AI approaches to this task was my question.
What sort of tasks are you saying? What
Generative AI approaches to this task.
Let me say one thing. We tried certain things, but I just read the NOGAD paper about 8 days ago. Okay, I want to rethink what I've thought about before I say anything more, because they've done some things which obviated some of the problems. They go, for instance, from LaTeX into a Markdown language before they do the mapping, and that actually saves them a lot of effort. And I think that's a really smart thing to do. So I want to think about things before I actually go and open my mouth. And I think the work is really nice. The paper is good. It's a very nice thing. And I tried the software transfer. It's fun. It does have some issues, but it's really good.
Awesome, Pedro. Thanks so much. Thank you. Thanks, speaker, again.